Hello Year 9 and welcome back to another lesson. Today we are doing about work done, and luckily although it is more maths unfortunately, luckily this is one of the easier calculations today. So what I want you to do is I want you to write the date, title and LO, and then I want you to pause the video and I want you to try and do the starter questions, please. Okay, so answers to the questions. So number one, what is the formula for kinetic energy? So kinetic energy equals a half times mass times velocity squared, or speed squared. Number two, how can we increase the amount of kinetic energy something has? So if kinetic energy equals half times mass times speed, then if you increase the mass, then that is going to increase the kinetic energy. So if you increase anything on this side, it's going to increase what's on this side. So if you increase the mass or the speed, then the kinetic energy is going to increase as well. Okay, number three, if you stretch a hair bubble, what kind of energy are you providing it with? You are providing it with elastic potential energy. And number four, what does the K stand for in the elastic potential equation? It stands for spring constant. Okay, energy transfer. So energy is transferred mechanically, so by doing work, electrically, moving charges, by heating, or by radiation. So those are the only ways that energy can be transferred from one type of energy to another. A system is a word to describe an object. When the system changes, energy is transferred. So this is a scientific way of explaining an object, what it is. Okay, so for example, I'm not explaining this very well. For example, if me as a person, if I jumped up in the air, then I am the system. Okay, so I am the object that is moving and energy is transferring, because as I'm jumping up in the air, then my kinetic energy, so energy when I'm moving, is transforming into gravitational potential energy because I am now off the floor. Okay, so I am the system in that scenario. Another scenario, a car driving down the road, the car is the system. Okay, so it's the object that we're talking about that has the energy transfers in it. A closed system means that energy cannot enter or leave. So I want you to pause the video a sec and write down all the important bits from this slide. So energy can be transferred mechanically, electrically, by heating or by radiation, and a system is just a fancy scientific word to describe an object. And you can write down any examples I've said as well if that's going to help you. And today specifically we are talking about energy that is transferred mechanically. So if you transfer energy mechanically, you are doing work, and that's what we're talking about today. So energy transfer. When a force moves on an object, energy is transferred and work is done. So technically, if you've got a pencil on a desk and you pick it up, you have mechanically transferred energy into that object. So work has been done. It's called work done. Okay, so whenever there's an energy transfer, then it's called work done. So those two things are the same. So work done is the same as energy transferred. There are useful energy transfers and wasted energy transfers. Okay, so an example of a useful energy transfer is when I press the switch on my hairdryer, the electrical energy is transferred into kinetic energy to make the fans blow around and to dry my hair. So that is useful energy transfer. The wasted energy transfer is that it also makes a really loud noise, which isn't needed. Okay, so that is wasted energy. So when we're talking about useful energy, it's the energy that's transferred into the object that's the object's job, that's the object's purpose. So the hairdryer, its purpose is to blow air out. Okay, so kinetic energy of the blades to dry hair, that's the useful energy transfer. But the hairdryer isn't made to just make a really loud annoying noise. Okay, so the sound that is produced, that is wasted energy. So I want you to again pause the video and write down anything important from this page, please. Okay, example. So here we have a very beautiful little unicorn. Okay, and that is our system. So remember, system is what we use to describe an object. So the unicorn is our system. Now, when this unicorn jumps up over the rainbow, it has transferred its kinetic energy. So remember, kinetic when it's moving, it has transferred its kinetic energy into gravitational potential energy because it is now above the ground. So work has been done. Energy has been transferred, work has been done. Okay, the formula for work done. So work done equals force times distance, and that's it. There's no times in by a half, no times in by gravity, no squares involved. Okay, it's just force times distance. So now we'll go through the units. So force is in newtons, so that's a capital N. Distance is in meters, so that's a lowercase m. And work done is in joules, because we're talking about energy transfer. So remember, whenever we're talking about energy, it is measured in joules. Okay, example of using this formula. Luigi jumps 2 meters in the air with a force of 13 newtons. What is the work done? So work done equals force times distance. That is our formula. And what we need to do is, we've got the force here, which is 13 newtons. So 13, and then we've got the distance, which is 2 meters. 13 times 2 equals 26 joules, and that is all we need to do. Okay, so these are really simple calculations. Now, on to rearranging the formula. So we draw our triangle, and this is just like a regular formula triangle with one thing on the top and 2 things at the bottom. So if we wanted to rearrange it to find out the distance, we cover up the distance, and then we are left with distance equals work divided by force, and that will give us our distance. Okay, same with force. So if we wanted to figure out what force was, we'd cover it up, and we would be left with force equals work divided by distance. Okay, and it's as simple as that to rearrange the formula. So what I want you to do now is I've got a big list of questions that I want you to work through. The answers are on the same page. So what I want you to do is, because there's hints and stuff next to it, you'll see when you open the document, but it would probably be easier if you just zoom right in on the question so you can't see the hints or the answer. Try it for yourself. If you're a little bit stuck, scroll right a little bit to look at the hint. If you're really stuck, then there's a second hint, and then I want you to try, and then you can scroll all the way across to the answers to mark them. Okay, I want you to send a photo of not all of these calculations. I'm not expecting you to do every single one, but I want you to send me a photo of the first 5 calculations that you did and your answers, please. So make sure you've marked them yourself in a different colour, and I want you to attach these on to show my homework, please. So just the first 5 questions. Do not send me a picture of all of them, please. Okay, I hope you have a wonderful day.